So 4.1, 4.6, interactive notebook review. This goes in your interactive notebook. We got it ready to go. You have your highlighters. Hopefully you need one of each color because we're going to make it so beautiful so that when you go use it on the exam, you know what we were talking about. X-intercepts. Can anyone tell me what my x-intercepts are? And we're actually going to do something different today. We're going to do something different, so hold on. Because it's like a review day, I'm going to give you raffle tickets, but you have to raise your hand to get them. Go ahead, Dylan. -3 and 1. So you have two x-intercepts. I have -3, so -3, 0. And I have 1, 0. Those are my x-intercepts. So -3, 0, and 1, 0. Write what I write. Sometimes I write bigger, and you can even put in x-intercept so that you know when you go back. Awesome. Who knows the y-intercept? Go ahead, Evan. 0, 3. Awesome. Okay, 0, 3. So this guy right here is your y-intercept, and it is at 0, 3. We're getting better at this, and that makes me very, very happy. All right, for 2 tickets, see if I get it right. Knocky. I'm really bad at pronouncing, so go ahead. X equals what? 3. Your axis of symmetry?
Oh, no, 1.
Just 1?
-1.
-1, good. Okay, I'm going to use a different color here. Equals -1. And that guy is right here. And I love, love, love how he told me it was x equals -1. Because if you write -1, then it's wrong. Well, it's not all wrong. You get like half your points. Because -1 is a number. X equals -1 is a line. And that's what the axis of symmetry is. All right. Raise your hand for the vertex. Go ahead. Yep. -1, 4. Awesome. Okay. This is our vertex. -1, 4. Okay. You guys are doing great. Raise your hand. Concave up or concave down? Who haven't? Nick, back there. Down. Very good. Doing good. Doing good. All right. Next one. Is it a max or a min? Go ahead. Max. A max. Very good. I'm going to circle that. It's a max because it's concaving down. Do you have any questions on anything we've done so far? Is there anything that confused you that we just did? If not, then I'm really, really happy because then you're going to do very, very well on the exam. Okay. All right. What is my domain for all parabolas? Go ahead, Dylan.
-infinity, positive.
Good. -infinity to positive infinity. Okay. Take a second. Give everyone a shot. Because the range is the most common error in all graphs. So from quadratics to polynomials, we just took an exam in my other class. Almost everyone got the range wrong. So this will be a 2-ticketer. So give everyone a shot really quick. I'll give you 30 seconds. Okay, hopefully you can look at it. You always want to look at your vertex. So give it a try first, and then we'll talk about it. All right, who's got me? Go ahead.
Like -1.
What'd you say?
-1 and positive 8.
No. -1. So here, let me explain this. -1's x. Remember, range is y. Go ahead. Good. -infinity to 4. So -infinity to 4. Let's close that bracket because it's included. So let me explain that so you know. Don't write this down, or if you want, you can. Your range is always your y. So think. Here's -infinity. He's going all the way down. And look, it goes all the way, and it stops at 4. That's why it's the range. It stops at that y value 4. That's the way I look at it. Read it from the bottom to the top. Awesome. Good job. Get out your 2 highlighters for interval of increase and decrease. Okay, stay consistent here. Interval of increase, I'm going to take 1 highlighter. Is the left side of the parabola or the right side of the parabola interval of increase or decrease? Or increase? The left side, good. Look at this. I'm increasing. Watch as I go up. That's increasing right there. 4, 2 tickets, because this is a hard one. Ooh, it just kind of went down on me there. Or not. What is happening? Did you see that? Okay. Who knows the interval, though? So, yes, you are right. This is where it increases. I don't know why it's doing that. Does anyone know the interval? No. I almost had it. I was thinking. What do you got over there? Is that a hand? What do you got? This is a hard one. It's probably one of the hardest ones besides the range. I meant the X out of it. Remember, with your interval of increase and decrease, you are always using your X values. Okay? So we are, wait, where'd it go? There it is. All right, try this again. So let me explain the first one, and maybe you can get the next one then. So I am going from, you look at your X values, so go ahead and write that somewhere. X values. All right, Tiana gave me my Y. You got to think of your X, and it's always the X value at your vertex. So I'm going to go from, over here is negative infinity, and I'm going to go all the way up to negative 1. So negative infinity to 1. Now you start where you left off. What'd you say? It is the right side. So you're going to go from where you left off to the other direction. So does anyone know what I'm going to do for decreasing? Different color here. You're right with a positive infinity, but not the negative 2. So you see how it changes at negative 1 right here? And then it goes. Okay. I don't know why this isn't working. So we're going from negative 1 to infinity. You won't have interval of increase and decrease on the exam for chapter 4 because we're going to still practice with it in polynomials. So don't feel like you have to stress out about that. But it is good practice for the future. We got to get going here. The function has an absolute max or min. What did we say it was? A max. Of what number at x equals what? So this is always going to be your vertex. You just need to figure out what goes where. Of 4 at negative 1. Here's the trick. Well, I know the x value of my vertex. It's negative 1. Okay? This is one of the hardest parts about this class, is the graphs. And I understand that. But we're going to do it so much that hopefully you get better at it, because a lot of Math 3 is a lot of graphing. So that's why we do it so much, and I keep putting it in your interactive notebooks for a reason. Okay? And if you want to make a note here, it's always your vertex. That's where those numbers came from, 4 and negative 1. All right. Here we go. Let's see how we do here. Give it a shot. If you're using pen, don't put it in yet, but give it a shot if you're using pencil. The standard form, we all know it. It's in your interactive notebook. What possible values can A and C have for this function right here, this graph? Okay. What does A always tell me? Always. In your standard form or any form. Yeah, if it concaves up or down, what's going on for this one? It's going down, so what is A going to be? Negative, good. So your A value tells you it's going to concave down, and it's negative because we're concaving down. So right away, I can cross off C. So it's a process of elimination here, because on your exam, you will have some multiple choice. And you can cross off A, because of the positive. It says positive. So now you have a 50-50 shot, and that's why I'm trying to get you used to it, because you can narrow it down. C, what is your C in your standard form? Let's see if anyone remembers. That is if we're in vertex form. Yeah. Yeah, C is always your y-intercept. Y-intercept. And if you ever forget that, go back in your interactive notebook and it's in there. So look at where this is. Is that going to be positive or negative? Positive. See how it's above right here? It's in positive. So you're kind of just interpreting the graph here. So we have A is going to be negative and C is going to be positive. Okay. This, I literally took it from your exam and I did something with the graph. I might have like rotated it in a certain way. Okay, so you make sure that you write down what I write. All right. Whew. Time flies when you're having fun, right? Okay. Create a function given the vertex and a point. So this was a toughie for you guys. Lots of solving, but we had 3 steps doing this. So here we go. We had 3 steps. Step 1. Remember, we had it always in vertex form. The more you write it down, the more you will remember it. That's vertex. If I give you vertex, you should automatically think I'm going to be in vertex form. Step 1 is to plug in all the functions, all the values. So I know my vertex. I have h equals 2 and k equals -5. And my point, x equals 3 and y equals 1. That's given to us. You need to know that vertex is going to be your h and your k value. So our first step is just to plug those bad boys in. So y is 1, so I'm going to put that in. Leave a alone. Plugging in x, which is 3. Plugging in my h value, which is 2. And plugging in my k value, which is -5. Questions on how I did any of this part? This is the easier part, and then we're going to get into the more complicated. Your exam's only I think it was 12 questions, 14, so it's not long. It takes a long time to do these problems. All right. Orders of operations, step 2 is to solve. What is 3 minus 2? 1, and what's 1 squared? 1, good. So I have 1 equals 1a minus 5. And now we're almost there already. How do I get a all alone? You got this. It's already subtracting, so what's the opposite? Add. Very good. Ooh, it is hot. So then I have 6 equals a. You have one final step here, and again, these steps are in your notes. In your interactive notebook. So if you ever get stuck, they're in there. And now there's another one. There's another example of it. So step 3 is just to plug it back in. F of x equals, all I have to do is take this 6 and plug it in. That's our only step here. Leave your x and your y alone. And this is your final answer. Oop. You're trying to create a function. You need an input and you need an output value. Whew. Good thing the back page is a lot easier. The front page was hard. That's why I put it first, to get it out of the way. Go to the back. You guys were really good at this, so stick with me here. I know it's Friday, month in now, so congrats to you. You've made it a full month into school. Describe the transformations between the two. What does this negative tell me all the way out in the front? It's going down. What is that math term, though? The concave's down, but what's the transformation term? Reflecting. Good. It reflects over what axis? X. Good. Then you have this 4. What does this 4 inside mean? If you don't remember, there's a bright green chart in your interactive notebook that can tell you. Yes? Good, right 4. I missed one. This 2. What does a 2 all the way out in front mean? It's greater than 1, so it's going to stretch or compress. Stretch, good. As the day goes on, it gets hotter and hotter in the school. What does this all the way out in the back mean, plus 1? What? Up or down? What is it? Up. 1. Good. Okay. We are going to stop because I can just see your faces right now, and I think we've done enough.